Hello everyone, I'm Nikhil from CAC 3rd Sem B section and my teammate is Nitin Paramkar. So our topic for Javathon is 3D renderer. So most of the people they think that making a 3D renderer it requires some inhuman knowledge, but thankfully that's not always the case. So of course like if you're building a 3D applications with fluid graphics, you'll be much better off with OpenGL or WebGL. But our attempt here is to understand how real modern engines do their black magic. So our 3D renderer, it's using no dependencies, so it's basically zero dependencies apart from Java APIs. So we'll be covering up this thing in 6 steps. You can see a GUI setup, defining few classes, and one more render class. We'll be implementing Z-buffer, shading effect, tetrahedron to sphere is the last topic for us. Okay, so let's begin with the first topic. The first one is setting up the GUI. So here code is also structured in same way as there are a few number of points. So you can see inside frames there will be six Java files which will be depicting the outputs of these 6 points. And this is the main class. Like it's the, so we'll be covering it in 6 steps. So let's begin with the first step. The first one is setting up of GUI, graphical user interface. So we'll be initializing a JFrame with sliders, horizontal and vertical rotations. We'll be using a JPanel as the main rendering area. The resulting window with somewhat will be resembling this. So let me show you the code for the same. So you can see Java frame1.java. So whenever I run this kind of thing pops up, and this is the sliders in X and Y axis. So this is our basic frame we'll be using in the next. Second is we'll be defining few vertex, triangle, and matrix 3 classes. So vertex class it represents a point in 3D space, and triangle represents a 3D triangle. Triangle it represents a 3D triangle with three vertices with a color. And matrix 3, it represents a 3 cross 3 matrix with the methods for matrix multiplication and vertex transformation. So you can see these three rotation matrices. Like if you want to rotate any triangle in XY direction, so we'll be multiplying that particular triangle coordinates with this matrix, rotation matrix over here. The same goes with YZ and XZ axis. So at this point, our wireframe of the project is completed and it somewhat looks like this. So let me show the code for this. So you can see frame 2. This is a frame2.java. So this is the code for this. First thing is we'll be doing the same, like setting up the sliders and those stuff. And next thing is we'll be making four triangles. We are first trying to make a tetrahedron. So we'll be adding these four triangles with different colors. You can see white, red, green, blue. And then we'll be making those same transformations which was shown here in the image. Cos theta minus sin theta for XY direction and all those things. So let me run this. Yeah, you can see. For the code is here. You won't believe that this actually is a tetrahedron. If I slightly try to adjust this slider over here, the x-axis, you can see how it's moving. The same applies for the y-axis. So this is just the basic wireframe for the tetrahedron. Next steps will be filling up with colors and so the next step is render class. So it initializes the GUI components and rendering panel. The central panel renders color triangles in 3D space using buffered image for improvised performance. And then triangles are transformed based on the combined horizontal and vertical rotation from these sliders. So we'll be getting output somewhat similar to this image which is shown here. Output for the third point that is render class. So here we have frame3.java. You can see the four triangles which are added. Then we'll be giving colors to them. For this, you can see that tetrahedron is being rendered, but you can see there's one flaw with this. Like whenever the blue color goes out of the side, but it's still visible as like it's painted on top of this triangle. You can see this. This is the problem because we haven't implemented Z buffering yet. So it's not able to differentiate that which triangle is close to user and which is away from the user. So we'll be implementing that in the next part. So you can see the next part is Z buffer implementation. We'll be implementing a Z buffer for hidden surfaces removal during rendering. And this rendering panel, it uses a Z buffer for depth calculations, enhancing the visual quality of the 3D object. So you can code for the same over here. In 4.java. You can see there will be an array. Okay, so this is it. The idea is to build an intermediate array during rasterization that will store the depth of last seen element at any given pixel. So whenever we'll be rasterizing triangles, we'll be checking if the pixel depth is equal to the previously seen and only the color and will be only color the pixel if it is above the others. So so with that logic, we'll be able to fix that issue that blue color is not being dominant on other colors. And the reason for blue color being dominant is also that we have added it as a last color over here. You can see we are adding color white, red, green, blue. So blue color was the last and hence it was dominant. So now when we run this, you can see that blue color is no longer dominant. So whenever blue color is away from the user, it's not visible to them. So we have implemented a C buffer for this thing. So the next thing is to implement shadows with shading effect. Shading effect is applied to color triangles based on the angle of incidence, that is angle cost of the light source and normal direction. And we are defining a get shade method for shading colors based on given shade pack. You can see the output will be resembling this. You can see here that green and red color are kind of shaded off, and blue color is highlighted. It is because green, and red color are away from the user's point of perspective. That's why they got a shadow on them. So this is the code for that. You can see we have implemented a get shade method. So it will be giving the colors, and it will be returning a new color with red, blue, and green. So based on that, particular triangles will be rendered accordingly. So let me run this. Yeah. So output, you can see the green color, the intensity of green color is decreasing as it is going away from the user. And the same is the white color. You can see the white color is also fading. You can check it out in any X or Y directions. You can see the red color is getting faded. So this was the final output for a tetrahedron. And our next step will be converting this tetrahedron into a sphere. You can say tetrahedron into a sphere. We'll be implementing an inflate method to subdivide triangles and adding detail to the scene. The final result is a dynamic 3D rendering of a sphere. So yeah, now let's see the code for the sixth frame. So this is it. It's actually pretty much similar to the frame 5. The code is almost similar. The only thing that have been changed is this inflate method. The inflate method has been added. So basically, we are repeatedly subdividing each triangle into four smaller ones. You can see here four smaller ones, and then implementing them, like inflating them basically. So we'll be returning this result. So let me run this. So yeah, you can see this is final output where you can see each and every like you can see the triangles which is been inflated. It's not a perfect spherical kind of sphere because it's been inflated by tetrahedrons. You can see different colors, and you can slide it in X and Y directions. So this is the final output. So if we want to have a recap of all the steps that we have done, first thing is to populating a list of triangles with initial vertices and colors. If you remember in the second step, we were creating classes such as vertices and triangles. Vertices was actually holding three values of X, Y, and Z direction, and triangles was implementing these vertices and then adding an extra field of color with them. So populating a list of triangles with initial vertices and colors will be our first step. And the next step is applying the rotation transformations based on the slider values. rotation transformations, we are referring this formulas, and then we'll be applying them based on the sliders value. And the next one is to implement the Z buffering for hidden surface removals, and that's how we got rid of blue being dominant. The next one is painting. So each pixel is being painted and rendered on the panel based on the transformed vertices and shading. So adding a little bit of shading and which pixel is should be visible to user and which pixel should not be visible, and all of this thing is taken care in this shading effect and debuffering, these two points. So yeah, this is the recap of this of our Java project for the Javathon. So yeah, that is it. Thank you. Have a good day.